In this video, we're going to go through some examples of using radiolabeled oxygens in CATS mechanisms. So first example, we're looking at a carboxylic acid paired with OCH3-. Notice that oxygen's radiolabeled. Because of the acidity of that carboxyl proton, I'm going to expect that when I combine with a radiolabeled methoxide ion, that I'm just going to deprotonate the carboxyl oxygen atom, and then I'm going to form a neutral alcohol. So the O18 in this example is never ending up in our structure. It's just going to be attached to the oxygen atom here. Now, that's a radiolabeled oxygen atom, and one of the details that I find to be helpful just in thinking through other examples too is that if you ever have an oxygen that's radiolabeled and it's connected to an alkyl group, right? Connected to an alkyl group there, it will never not lose, excuse me, let me rephrase that. It will never lose that R group. It will not lose the R group. Let's see how that detail will be important in the next example. So in the next example, we're reacting a carboxylic acid with a radiolabeled methanol molecule. This will be an example of our Fischer esterification reaction. That radiolabel is only going to end up in the OR component of our ester product. It can never end up there. And the radiolabel can never end up there because for the radiolabeled oxygen to end up in the carbonyl there, well, the oxygen would have had to lose its alkyl group. And we said that if a radiolabeled oxygen has an alkyl group, it should not lose that alkyl group. That structure is not possible in this example. We've maintained the bond to the methyl group. So in this case, we only have the radiolabel end up in the the functional component there. Could never end up in the carbonyl oxygen. Never ends up here. And that's specific to this Fischer esterification scenario. If we move on to the next example, here we're going to assume that there's a large excess of our radiolabeled water, and we're doing a hydrolysis reaction. Mechanistically, we'd protonate the carbonyl, water would then attack and add in. We deprotonate the oxygen atom, and then we'll protonate the OR component, because we're eventually kicking that out of the structure, and that alcohol would, be a byproduct. Now, from the intermediate, if I were to collapse using my unradiolabeled OH oxygen, that would end up creating this structure here. And if I were to collapse and eliminate my leaving group using the radiolabeled oxygen atom, that would create this structure here. We could therefore say that these are the initial carboxylic acids that would be obtained, but we can then also get a product where the O18 label is in the carboxyl carbonyl and the carboxyl OH portion. Let's track how that's formed specifically. If you imagine taking either of those initial radiolabeled outcomes, and then you imagine that continuing to react with the radiolabeled water, we protonate the carbonyl, water then attacks and bonds. We're ultimately, because of the large excess of our radiolabeled water, favoring then in the tetrahedral structure, protonating the oxygen component that is not radiolabeled, and then either of the two radiolabeled OHs can collapse and eliminate your leaving group, which is just the regular water. And that favors ultimately incorporating two O18 oxygens into your final product. So as we react, further to make that radiolabeled outcome, it's not like I'm changing the functional group. I'm just reacting the carboxylic acid with more water, which is forming a carboxylic acid that has other radiolabeled oxygens. Okay, but going back to the last example, in example 2, mechanistically, we protonated the carbonyl, attacked, added in. I would then deprotonate the oxygen atom that attacked. I would create this neutral tetrahedral, protonate this oxygen atom, and then collapse and kick out water. And so the radiolabel, as we prove it out mechanistically, can only end up in that OR component. So I want you to look at these 3 scenarios and recognize that really, when asking about a radiolabeled oxygen scenario, it's really a mechanism question, and you're just asked to track the mechanism and see theoretically if the mechanism proceeds, where is that radiolabeled oxygen ending up? These are more or less mechanism questions.